So today I'm going to talk about a qualified exam problem from 2018 June. So the problem asks us to classify the groups of order 2018, and given that 2018 equals to 2 times 1009, where 1009 is actually a prime number. So my attempt is, first of all, consider the case that so let's denote this group equals to G. So consider the case that G is abelian. In this case, we can treat G as a finitely generated module over PID. So we can apply the structure theorem. And we know that G should be isomorphic to Z mod MZ, direct sum with Z mod NZ, where Mn are prime powers. However, we know that the cardinality of G is 2018, so it means that M times N should be 2018. And this really leaves no more choices for M and N. So we know that G is isomorphic to Z mod 2Z, direct sum with Z mod 1009Z. So this is the case that G is abelian. And case 2, suppose that G is not abelian. Then of course G is not cyclic. Then it means that G has no element of order 2018. And now let's consider the Silo theorem, the normal subgroup, the subgroup of order 1009 and subgroup of 2. Because by Silo theorem, we know that there should be a subgroup of order 2 and a subgroup of order 1009. So N1009 equals to 1 mod 1009. And it also divides 2. So this gives us that N1009 equals to 1. So the Silo 1009 subgroup is normal. Call it H. And since it is the subgroup of order prime number, then it should be cyclic. So we can write H equals to the group generated by X, where X is some element in G. And Silo theorem also tells us that there should be a subgroup of order 2. So it means that there exists an element Y in G, where Y has order 2. So now let's consider the subgroup generated by XY. Since X has order 1009 and Y has order 2, we know that 2 will divide the order of this subgroup, and also 1009 will divide the order of this subgroup. And since this is a subgroup in G, so it has order less than or equal to 2018. So actually it gives us that xy has cardinality 2018, and so xy is exactly our G. And since x has order since the subgroup generated by x is normal, we know that yxy inverse equals to x to the power I for some I greater than or equal to 1 less than 179. So we have x equal, so notice that x equals to exe inverse, and the reason I write this is that y has order 2, so notice that y squared equals to e, so we replace e by y squared and e inverse by y to the negative 2. So this can be treated as applying this conjugate for twice. So this equals to xi squared. And notice that x has order 179, so we have 179 divides I squared minus 1, and I squared minus 1 equals to I minus 1, I plus 1. And since 179 is a prime number, so it gives I equals to 1, or so it gives that I equals to 178. Yep. So I gives 178, so we have yxy inverse equals to x to the power 178, and notice that x to the power 178 is actually x inverse, because x to the power 179 is just the identity. So we have yxy inverse equals to x inverse, and yx equals to x inverse y. And the group can be described by, so G now equals to the group generated by xy, and where x to the power 178, x to the power 179 is identity, y squared is identity, and yx equals to x inverse y. And this is exactly the dihedral group. D179. Yep. So the group of order 2018 is either isomorphic to Z mod 2Z cross Z mod 179Z, or dihedral group of 179. So one more remark is actually this result works for every group of order 2p, where p is a prime greater than 2. Yeah. And that's all.